Hey guys, today we'll be talking about development of the heart tube. Firstly, in the embryo where this heart is developed, it is developed in the cardiogenic area of the intraembryonic mesoderm. And later, how does this originated? It is originated by development of the two endothelial heart tubes. These two endothelial heart tubes later fuse it to form a structure called like this. And now let us see this heart tube in detail and how each part of the heart tube has developed into a future structure. Now, this is the typical heart tube. So this is the atrial end, this is the venous end. This atrial end is called bulbous cordus and this venous end is called sinus venosus. After the bulbous cordus, we find the primitive ventricle, and after that we find primitive atrium. Now let us look into different parts and how do they develop in the future. Now first let us see about this bulbous cordus. This bulbous cordus will be having three segments. So initial, this is the proximal one-third part, and the second, this is the conus part, and this is the truncus arteriosus. This proximal one-third is just named like proximal one-third and no special name is given to this, like a conus and then truncus arteriosus. Now, how do these structures develop into our future structures? See, this truncus arteriosus, by formation of a spiral septa like this, it will be developing into the aorta and pulmonary trunk. So this truncus arteriosus, by formation of a spiral septa like this, it gives rise to ascending aorta, later the arch of aorta, that finally becomes a descending aorta, and the pulmonary trunk on the other side. Now the conus will be forming the outflow chambers of the ventricles, both the right and left ventricle. They'll be having two parts, the outflow part and the inflow part. The outflow part of the ventricles is formed by this conus, and the proximal one-third, this alone forms the right ventricle. It will be forming the right ventricle. This is about the bulbous cordus. Now when you look here, this is a bulbous cordus, this is a primary ventricle. There is seen a junction between this bulbous cordus and primary ventricle called bulboventricular sulcus, Now let us see what happens to this bulboventricular sulcus. That is the fate of bulboventricular sulcus. This bulboventricular sulcus, this will be separating this developing right ventricle from the primitive ventricle. Actually, it is called the foramen of interventricular foramen. This foramen later get filled up to form interventricular septa. Now, coming to the next part, that is the primitive ventricle. This primitive ventricle in future get developed into the left ventricle alone. So the right ventricle is formed by the proximal one-third of the bulbous cordus and the left ventricle is formed by the primary ventricle. After the primary ventricle, between the primitive ventricle and primitive atrium will be having another junction called the atrioventricular canal. Now let us see what happens to this primitive atrium and atrioventricular canal. Yes, now this is called the primitive atrium. This is the atrioventricular canal that is separating the primitive ventricle and primitive atrium. This primitive ventricle, it just split up into the right atrium and left atrium by an interatrial septa. Now, this atrioventricular canal, they get split up to form the tricuspid valve and the mitral valve. Now, between this primitive atrium and the sinus venosus, we'll be having another junction called the sinoatrial orifice. Now, let us go to the sinus venosus. This is called the sinus venosus. Sinus venosus will also be having the three segments. The three segments include body, the right horn, and the left horn. This entire body, this is called the sinoatrial orifice. By the enlargement of the sinoatrial orifice, get absorbed into the right atrium, and this all body also forms the smooth posterior structure of the right atrium. We know right atrium will be having smooth posterior part, rough anterior part, and the smooth posterior part is formed by this body of the right atrium. Now, what is the fate of these horns? These horns are some projecting structures below, and each the horn is getting there are three sets of veins adjoining these two horns, namely the vital line vein, the umbilical vein, and the common cardinal vein. The vital line vein is present more medially, and the common cardinal vein is present outside. This vital line vein, it is derived from the yolk sac on the both the sides, and this umbilical vein will derive oxygenated blood from the placenta, and the common cardinal vein, it drains the impure blood from different parts of the body in the fetus. Now, this left horn, let us see what is the fate of this left horn. This left horn completely gets regressed, and whatever so the remaining part will become a small structure like this called the sinus, coronary sinus. So the left horn completely regressed, and finally the remaining part forms the coronary sinus. Now, what happened to this right horn? Unlike the left horn, it is not like that. It is getting absorbed into the right atrium along with the body, and these veins get transformed into different structures. Right vital line vein will become a part of the superior vena cava. This umbilical vein gets regressed, and common cardinal vein will form the terminal part of the inferior vena cava. As this right horn is getting absorbed into the right atrium, this superior vena cava and inferior vena cava will be opening into the right atrium. So, now we have seen how different parts of the heart tube are developing into different parts in the future. Now we'll see where this is happening, where all this development is seen. This all development of the heart tube is seen in a very small space called the pericardial activity. Pericardial cavity. In this pericardial cavity, all the activities of this heart tube is seen. Initially, we'll be finding this heart tube like a horizontal tube-like structure because only bulbous cortex is there. Later, it has formed a primitive ventricle. But as the development goes on, this primitive ventricle gives primitive atrium, and then the sinus venosus. These parts are going to become enlarged. On enlarging, what happened? This space will not goes on increasing. Now, what happens to the tube goes looping. A bend like this, a bend U-shaped loop is seen, which is nothing but the bulboventricular loop. Why so it is called bulboventricular loop? Because by the enlargement of the bulbous cortex in the primitive ventricle, all the structures have got enlarged and that formed a U-shaped loop. Hence, it is called bulboventricular loop. What this U-shaped loop remains the same? No. Still, there is an enlargement of the particles. Still there is enlargement of the parts. Now, later what happened is, by still enlargement, still development, this U-shaped loop has become the S-shaped loop. Now, what happened? The S-shaped loop it has become. Now, what happened in the U-shaped? What happened in the S-shaped? Let's go back to our initial picture. Yeah, this is what the picture. When what happened? This is the U-shaped loop. Whenever the U-shaped loop happened, there will be a turn of like this. There is a slight bend between the bulbous cortex and the primitive ventricle. But whenever there is a S-shaped loop, this primitive atrium sinus venosus goes behind this primitive ventricle and the bulbous cortex region. That is why the reason this looping phenomenon is responsible for the relation of the atrium in the posterior aspect of the ventricles. So why do we find this atrium in the posterior relation of the ventricle is nothing but the looping phenomenon. First initially the U-shape and then finally the S-shape brought this atrium posterior behind structures of this primitive ventricle. Okay guys, all this is about the development of the heart tube. Thank you for watching.